Okay, what you're seeing is a flashlight shining on a pop can, soda pop can, Dr. Pepper can to be specific. We see a lens here, the water lens, the 3-inch diameter water lens, and we have a movable screen back here. When I shine the light on the Dr. Pepper can, let's see what happens to the screen. Okay, I shine the light in the Dr. Pepper can, and the light from the Dr. Pepper can actually appears on the screen. If I block the Dr. Pepper can, if I move my finger across it, it blocks out. Now, if I move the lens or the screen back to just the right point, the Dr. Pepper can actually comes into focus. I see a P and an E there. You probably can't see it because of the limitations of the lens and the contrast. I can put my finger there and wiggle it back and forth. You see my finger wiggling, and you should see the image of my finger on the screen. Okay? So, if we put an object here and move the screen to just the right point, we can get an image of the object. The light bounces off the object, goes through the lens, passes through the focal point, which is about here, and forms an image over here. We have 3 important distances in this situation. The distance from the object, the can, to the lens is called the object distance. The distance from the lens to the screen where the object image appears is called the image distance. And the distance from the lens to the focal point, which we've seen before, is called the focal length of the lens. And these distances have a very simple relationship that we'll see. Just to look a little more closely, I'm going to move the Dr. Pepper can back further. I'm going to increase the object distance, in other words. Okay, now I'm shining the light in the Dr. Pepper can and nothing is in focus. However, if I incidentally, you can see the focal point where all the light tends to focus down on a point, and then we move past the focal point. And we get a point where we get a good image. I think the good image appears about there. Now, the Dr. Pepper can is further away. We see that, and here's my finger again. You can see the image of my finger wiggling, although you can't see my finger because I had to move out of the way. Okay? If you want to see something really scary, I can hold a very bright light in front of my face at about that distance, and you might, if I get my face in the right place here, I don't know if you're seeing anything or not, but you might have been able to see my face there. As the object moves further away, the image distance obviously decreases and moves in closer and closer to the focal point. The focal point is where an infinitely distant image would form, and we'll see the reasons for that later.